On exercise 2, we're going to be writing and graphing some equations of circles. So let's take a look at each one of these problems. Write and graph on number 1, the equation of a circle that is centered at the origin has a radius of 5 inches. On number 2, write and graph the equation of a circle that's centered this time at negative 3, 2. But this time, the radius is still the same, 5 inches. Okay. And then number 3, describe a series of transformations that would map the first circle onto the second one. Tying these things together in a way that's going to be totally helpful for you in Algebra 2 next year. All right, so let's do some work here. Writing and graphing, well, first of all, writing the equation. Let's focus on just that one part first. I think it's going to be pretty easy. Remember, we have ourselves an equation of a circle. It's right here. X minus h squared plus y minus k squared is equal to the radius squared. H and k is our center point. So we really just need two pieces of information. We need a center, we need a radius. It tells us that the center is the origin. 0, 0. This is my h and my k. And then it also tells me that the radius is 5. That's our r. Now let's put those things together and write our equation. It's x minus 0, x minus h, squared plus y minus k, which is also 0, squared is equal to my radius squared. And then we just clear it up a little bit. X minus 0 doesn't do anything, so it's just x squared. Same thing with the y squared. And then we can go ahead and square it out. 25. There is the equation of a circle, radius of 5, centered at the origin. And again, its connection to the Pythagorean theorem is pretty clear. A squared plus b squared is equal to c squared. All right, the second part of this is asking me to graph it. So what I'm going to do is I'm going to add a little piece of graph paper here. Let's see how this goes. I've got a sticky graph grid. It is this nauseating yellow parchment color, which I am totally going to change to white. Very tasteful. All right, let's make sure it's going to be big enough here. All right, that should be good. And wait, can I make it smaller grids? Whoa. Okay. Yep, there we go. So let me throw in an x and a y axis, which of course officially must be black. There's my x-axis. I mean y. There's my x-axis. All right, and then I have centered at the origin my circle, and then it has a radius of 5. So it would be like this. Like if I started at the origin, 0, 0 is not a point that's on the circle. Okay, but all of my points are 5 away from that. So I can go to the right 5, 1, 2, 3, 4, 5. I can go up 5 and go left 5 and then down 5. Great. And if I could visualize a circle that goes through each of these, maybe you had a compass or something. Draw yourself a nifty circle going through those points, and then just wait for it to perfect itself like that. Okay, yeah. Oh my gosh, it is perfect. There's my circle. Radius of 5, and it goes through all those points. Okay. All right, then. Now let's take a look at the second one. Why am I trying to change colors? Who knows? Write and graph the equation of a circle centered at negative 3, 2, and the radius is still 5. So my center, negative 3, 2. Again, that's our h and our k. And our radius is still 5. Our equation is going to be x minus a negative 3, which would make it x plus 3 squared, plus y minus 2 squared is equal to 5 squared, 25. So here's our new equation. And now let's graph that thing. So its new center point is at negative 3, 2. So let's see if we can plot that. Let's maybe change colors here. Negative 3, 1, 2, 3, 1, 2. It's this point here. But its radius is still 5. So I'm going to go to the right 5, up 5, and so on. Where's my yes? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and then again, try not to make a potato. Instead, make a circle that goes through these points. Look at this, is lovely. Burp. Man, if that didn't happen, it would have been one ugly circle. All right, let me see if I can pick it up a little bit. Nice, there we go. So let's look at these coordinates. Like each one of these coordinates, sure, we could very easily get the XY coordinates from the grid, but let's kind of think about this. Here we've got this center point was at -3, 2. My radius is supposed to be 5. I'm going to go 5 in all directions here. So if I were to count up, let's say going to the right 5, I would add 5 to my x-coordinate. 5 minus 3 is a 2. This should be at 2, 2, and I can definitely see it is. If I go to the left 5 spaces from -3, it should be at -8, 2. And then I can do the same thing going up and down. So this time it's going to affect the y-coordinate. If I go up by 5, it's 2 plus 5, it's at 7, so -3, 7. And then I can go down by 5. This time 2 minus 5 is a -3. Should be at -3, -3. It does look like that's where it's at. All right. Okay then, okay. Let's see. Let's look at what the last one is. Describe a series of transformations that would map circle 1, or the circle from question 1, to the circle from question 2. Well, it has the exact same radius. These two circles are congruent to each other, so it's not being stretched. It's just being translated, right? It's been translated by some sort of vector, right? I could draw that vector in sort of like that. And that vector moves it left by 3 spaces, and it moves it up by 2 spaces, right? So it looks like it is translating left 3 units. If I can spell that word, units, and up 2 units. You can write that in our, fancy geometric notation, which goes like this: t with a subscript of a vector -3, 2. Right, so that's essentially what's happening. It's the same circle. It's just been translated to the left 3 spaces and then up 2. As a matter of fact, that's another way that you can pretty much graph lots and lots of functions, is if you can boil it down to a very simple equation like this one. You can see that this one's a little bit more complicated than that. This one's a little easier to work with, and then think of this one as just being transformations on a simpler one. And that's a lot of what you do graphing-wise in Algebra 2. It's just that the transformations are not just translations. They can also be reflections, and they can also be stretching and shrinking. All right, what I'm going to do in the next video, I'm going to cut this one short for right now, but let's say I wanted to graph this thing in my calculator. Would I be able to do it? So that's the investigation that we're going to extend this with in the next video.